right? Don't get me wrong, you might need to add some input hardware and that might be there, but also another thing that has become easier, you know, with the safety device, you generally have, it's a hardwired safety device. You have two OSD wires that come off of that, and there are two, you know, safety chains, and you can wire that directly into a safety input card, right? Which you might already have other safety devices in that area and a safety input card that's located near to the device. And so now you're able to expand a safety system much more easily. Like say for instance, we use Allen Bradley's GuardLogix PLC, and then we use remote IO throughout the system. So let's say for instance, if we have an HMI station, the HMI station has an e-stop button on it. It also has a remote IO module in there, and has safe input cards, so that way the e-stop that's on that is tied right to that remote IO module, and the wiring for that e-stop is very minimal. There's like literally less than 3 feet of wiring for that e-stop. So if ever there's an issue where that e-stop is not working, we're able to troubleshoot that very, very easily. And also with the way these networks are being set up now you can also identify that e-stop stopped working before anybody pressed it, right? You can send pulsated signals through the e-stop that is essentially testing continuously, always, throughout its entire lifetime, if that e-stop is good. So there's not any conditions of Billy Joe hit that e-stop button and it didn't do anything, right? At least from a wiring standpoint, it can't be defeated, and it can't be, you know, the wiring can't be manipulated. Everything is in a much more safe condition. And this is able to be accomplished because of communication protocols, right?